Okay, so question 18. Determine the area of the largest rectangle that has one side on the x-axis. So one side along the x-axis here. And it has two vertices on the curve, which means that it's going up like that. Now we can see that this curve is going to be symmetrical, so that's going to help us. Because that means that when I'm looking for the area equals length times width, the length of this thing is going to be two lots of whatever that x value is. So our length is going to be two lots of the x value, and our width is going to be, when x is this, what is y, or what is that in our function? So we can substitute in x as our width. So it'll end up being minus, or e to the power of minus x to the power of 2. Okay, so express your answer in simplest form, sketch on the curve. So I'm going to make an expression for the area. I'll start writing in black. Area equals length is 2x times the width is e to the power of negative x squared. Next thing I'm going to do is take the derivative of it. Now we need to decide whether we're going to take the derivative or whether we're going to integrate it. Now when we integrate something, that determines the area underneath the curve. But in this case, our better chance to find the maximum area of this is to use optimization. So when we want to calculate things using optimization, we take the derivative of it, dy over dx, and we then let that equal 0. Okay, and that'll help us find the stationary points for if we express this as a function where it has the maximum possible area versus the minimum possible area. Okay, so A dash, we're going to have to derive this, which means we need to use product rule. So we're going to let u equal to x, which means u dash is going to be equal to 2. We're going to let v equal e minus x squared. And when I take the derivative of this, derivative of the top will come down, minus 2x, e, and then this doesn't get changed. Okay, so now I can chuck it into product rule. So the area is equal to 2x multiplied by negative 2x, e minus x squared, plus 2e minus x squared. We let it equal 0 because we're optimizing it. And I'm going to simplify what I've got in this step where I'm making it 0. So 4x squared, don't forget that there's a negative in front of that, e to the power of negative x squared plus 2e minus x squared, like that. Now, next thing I'm going to do is I'm going to apply factorizing so that I can get parts of this on its own. So here, this one and this one are common in both expressions. So I'm going to factorize that out. E to the power of negative x squared, bracket 2 minus 4x squared. To find 0 here, we'll use null factor rule, which means we're going to let each equation equal 0. So 0 equals e to the power of x squared, and 0 equals 2 minus 4x squared. So we'll solve this first one. Take this across and it will become a log with base e, or a natural log function. And anytime I see this, that is a math error. So this one doesn't give me a solution. For this one over here, I'm going to take the negative 2 across first. Then I'll take the 4 across by dividing it. So I'm left with a half is equal to x to the power of 2. Take that half across, and when I do that, take the to the power of 2, sort of square root the other side. When I do that, you end up with two answers, a positive and a negative case. So here, x equals positive and negative root 1 on 2. So we've now found what our x has to be, but we haven't determined the area yet. So I'm just going to scroll down a little bit. To determine the area, we're going to substitute in the positive case of this back into our expression for area. So area equals 2x, e to the power of negative x squared. We're going to let x equal square root of 1 on 2. Okay, so 2 times square root of 1 on 2, e to the power of negative root a half, and that is going to be squared. Now we're going to simplify. So let's remember that I can express this by saying that's root 1 over root 2. So this can be simplified again because the top can be simplified to just 1, and the 2 will stay on the bottom. Now, we don't like to have surds on the bottom of things, so we're going to rationalise it by multiplying the top and the bottom by root 2. So this will simplify down to root 2 on 2. So multiply it by root 2 on 2. Now these 2's will cancel out, and I'm left with root 2. Now we can deal with the second part. Let's remember that if something is a surd, that means it's the power of a half. The other rule that we need to apply here is if I have something on the inside of a bracket and it has a power on the outside of the bracket, your 2 powers will multiply. So here I've got a half times 2, which will make 1. So that will become e to the power of negative a half, because what's really happening here is it's minus 1 over 2 to the power of a half to the power of 2. This will cancel out to make it 1, so it's just minus a half. So what I'm left with is root 2 e to the power of negative half, or I could represent that like root 2 on root e if I wanted to. I'd probably have to simplify that denominator by rationalising it. So I would prefer this answer, but you could also rationalise it again, times them both by root e. That means this is going to become root 2e over e like that. And that should be our answer for the area. So this should be units squared.